Hey everybody, let's look at this problem right here as a good example of an angled projectile problem. So a football is kicked at an angle of 37 degrees with a velocity of 20 meters per second. Calculate A, the maximum height, B, the time of travel before the football hits the ground, C, how far away it hits the ground, and D, the velocity vector at the maximum height, and E, the acceleration vector at the maximum height. All right, so if they give you an initial velocity and an angle, the very first thing that you're going to want to do is resolve the vector. In other words, break it into its components. So here's the start of our triangle that we're going to break apart. Here's the hypotenuse, 20 meters per second, and at an angle of 37. Let's find this horizontal side first, and then we'll find the vertical side. So to find this horizontal side, remember, the Vx is equal to the overall velocity times the cosine of the angle. So we simply plug in 20 meters per second times a cosine of 37. Remember to be in degree mode, and we'll get roughly 16 meters per second. Over here for the vertical component, so the initial y velocity, because remember, this Vx will never change, but this will begin to change instantly because gravity is pulling on it. So the initial y velocity is the overall velocity times the sine of the angle. So 20 times sine of 37 will give us approximately 12 meters per second. So it's going to the side at 16 meters per second, and it's going up at 12 meters per second. So let's actually get to part A right here, the maximum height. Here's the important information that we need to know. We're going up at 12 meters per second. So here are some variables. We know that the time to the peak will only take 1.2 seconds. Remember, you take this initial velocity and divide it by 10. The first equation, by the way, is the one that proves that that's true every single time. So our initial y velocity is 12 meters per second. Our acceleration in the y is g, negative 10. And our final y velocity at the peak is 0 meters per second. There's a number of equations that you can use. I'm going to use the third one right here. If you plug every single thing in here that we just mentioned up above, then it will simplify down to this. Sorry, I'm using the fourth equation. So the final y velocity is 0 at the peak. It will simplify down to negative 1 half gt squared. And then if you plug in your time of 1.2 seconds, you'll get a height of positive 7.2 meters. So what's the B, the total time before it hits the ground? Well, as we just mentioned, if we throw it up at 12 meters per second, we know that the total time is 2 times the time to the peak. And so the time to the peak will be 1.2 seconds. So 2 times 1.2 seconds is a total of 2.4 seconds. So it'll take 1.2 seconds to get up, 1.2 seconds to get back down, for a total of 2.4 seconds. So next part C, how far away it hits the ground. So for this, we're going to need our horizontal information again. We know that our horizontal displacement is our horizontal velocity times time. This is the third kinematic equation. There's no acceleration in the x, so we just drop that whole acceleration term. Now we can simply plug in here. Our horizontal velocity is 16 meters per second, and this is important. It's the total time that it was in the air, not the time to the peak. So we plug in 2.4 seconds there. And so when you work that out, it will be 38.4. So we'll go 38.4 total meters to the side there. All right, now for part D here. So part D says, what is the velocity vector at the maximum height? Well, at the peak, the y velocity is 0, but there's still x velocity. So the only velocity is the x velocity. So it's simply 16 meters per second to the side, to the right, whatever you want to call it there is the velocity. Don't say 0. If you threw it straight up, the velocity would be 0, but now it's just the horizontal component. So last part here, let's do E. What is the acceleration vector at the maximum height? Don't let them trick you if they ask something like this. The acceleration is always the same for a projectile. It's negative 10 meters per second downwards. Always the answer on one of these types of questions.